Hello YouTube, this is Dazza the cameraman. Today is Thursday, September 28th, 2017, and this is a quick hangout with Astronomy Live, and we're discussing some images on this website called SkyView, which have been getting a little bit of interest lately, and there's some interesting questions that have popped up and what's going on with these images, what they are, and when they were actually captured. Because as we can see here, some of these images have a created date of, for example, this one here is September 27th, 2017. So is this a current image? So welcome along Astronomy Live. Thank you for joining me.
Thanks for having me on, Dazza, and getting this going so quick tonight.
You're welcome. So we've had a quick look at this together, and you've looked into this and you've figured out what's actually going on. So I'll let you take over and explain what we're seeing here.
Okay. If you want to put it over, I guess, on my screen for a moment, I'll show what my screen is sharing right now.
Okay.
So
Righty.
Here is an image that people are talking about, although the color palette might be a little bit different than what people are used to seeing. And if I scroll down here, there are more images of the same coordinates in different wavelengths. And so you'll notice here this image is titled IRAS 100 micron from the IRAS All Sky Survey Atlas. And these coordinates here, if you go onto Google Sky, appear to be blacked out. It appears that you can't see what's there. It's as if they've cut out that section of Google Sky. And that's what gets people so interested in that. And so we saw this object in black and white in the gallery you were just looking at. And if you were to scroll through that gallery, you would see that there appear to be many images of this object created today. And if you looked back yesterday, I'm sure you'd see the same thing yesterday and the day before that. So the question becomes, what is going on here? Because supposedly this is coming from the IRAS satellite. The IRAS satellite was a far infrared satellite launched in 1983. And it had a limited supply of cryogenic coolant that was necessary to cool its detector so that it could detect far infrared wavelengths and detect faint heat emitting from distant stars and objects. And when that cryogenic coolant ran out in about a year's time, the satellite was more or less useless because it was no longer able to see these far infrared wavelengths, especially at long wavelengths like 100 microns. And so it was unable to take more pictures in that wavelength. And it's no longer in use today as a result. It's a dead satellite just tumbling in space. But there appear to be new pictures coming from IRAS showing up on SkyView. And that's raised a bit of a question. On top of that, people are still wondering what this object is. This picture here, as a matter of fact, with this color palette, has been showing up in some conspiracy pictures I've seen online, posters and presentations and other things. And they are calling it the Red Dragon. They're calling it Nibiru, of course. And what this really is actually a double exposure of the planet Saturn. So as I mentioned before, IRAS had a limited supply of cryogenic coolant. They had 1 year to canvass the entire sky as best they could with this wide field infrared telescope. And because of that, there was no time to wait for Saturn to move out of the way so that they could get a shot of these coordinates. And in fact, while they were scanning this region of the sky, they actually scanned over the coordinates of Saturn twice on 2 different dates. And that led to this double exposure that you see in that picture. The dates were July 14th, 1983 and July 24th, 1983. And so if I go over here to Drop Canvas, if you see this link up here, I'm sure Dazza can put this link in his video description when all is said and done, because these 2 files, .tbl files, are tables that you can open up in a program like WordPad and view them. They are human readable tables. You can just edit them like you would a text file. And what you're going to find is columns of coordinates and the flux detected by IRAS at those coordinates. And up at the top, you'll see the time that those scans were done. And these 2 scans have 2 different dates associated with them. And those are given in what they call UTCS time. And so you'll see a heading on there, UTCS. Well, what is that? UTCS is an obscure way of denoting the time. It's seconds from the date January 1st, 1981. And so it's a very large number. Let's see, what is the exact number here? I forget what it was. It was something like, yeah, I don't even know. It's 7984395 dot yada yada yada. And then the other table has this other really long number. If you convert that to days and you add that to the date January 1st, 1981, that's how you arrive at the dates July 14th, 1983 and July 24th, 1983. And on those two dates, IRAS scanned that region of the sky. And if you happen to look at the coordinates of Saturn on those two dates, as seen from Earth, on July 14th, Saturn's coordinates were 13 hours, 47 minutes, 56 seconds, -8 degrees declination, 28 minutes, 2.9 seconds. And on July 24th, it was 13 hours, 48 minutes, right ascension, 57 seconds, -8 degrees, 36 minutes, 36 seconds. So a little bit different on those two different dates. And if you happen to call up an image from the IRAS survey, you can call up those specific coordinates from the IRAS site where you can get the raw data, and it will gladly overlay a crosshair on top of the image for you exactly where you specified the coordinates. And as you can see, those crosshairs for the coordinates I just read off match up perfectly with these two right objects in the image. And those are the same objects you see back here in SkyView. If I scroll up, it's actually this picture right here. It's the same picture. It's just in a different color palette. With the SkyView Virtual Observatory, you can create artificial color tables. And that's what you see down here. So the color table is colorizing the image based on the intensity image. And so very dim show up as deep red. Then you get into the greens, then really bright objects can even show up with a little bit of blue, which is what you see there for those double exposures of Saturn. And you can specify that when you perform a SkyView query. If I can get it to come over here. So I specified the prism color palette and plugged in my coordinates roughly, not the same as what I just read off, but in the same ballpark anyway, and called up those images. And let me come back here to this tab. So that's what we see here. The question becomes, why does it say that this was created today? Well, if you go back to the gallery, Dazza, if you'll take back your screen and present your screen to everybody so that we can see the gallery.
Right. Okay, there we go.
So it says created 9/27, 2048, 21. And actually, I believe that's in Eastern time, which is kind of interesting. They didn't even put that in Universal time. But anyway, that's the time that image was supposedly created. Well, this is a gallery that users are submitting the images to. And the created time is actually the time and date that it was submitted to the gallery. So Dazza, if you'll go ahead and refresh the page now, we'll see images have already arrived in the gallery. And so there we see a whole bunch of new images from various sky surveys. Sky Virtual Observatory provides images from much more than just IRAS. You can call up the WISE image from the newer WISE image survey, which was also in infrared. You can call up Swift X-ray images, all kinds of stuff. But anyone can submit images to the gallery. And so I'm sorry to keep juggling you back and forth, but if you can switch it back to my tab real quick, we're going to add an image to the gallery and see it appear there. Just let me know when you've got my screen up.
Go right ahead.
Okay, so this image we've been looking at just now, I'm going to click Add to Gallery. And it says this image will be displayed within a few minutes in the SkyView image gallery. So Dazza, go ahead and refresh the page again. And present your screen.
Present mine, yep. Okay, so now we're going to refresh the page. And there it is.
Voila. And sure enough, it shows a creation date of 9/27 at 21:51:12, and that's local time for me. That's Eastern time. And sure enough, there it is.
Yep, 21:51:12. That's the time. That's UTC, isn't it?
That's not UTC. That's actually Eastern time, unless my computer clock is way off. No, that's got to be Eastern time. That's local time for me here in Florida.
So the time here in New Zealand is 2:52 p.m. We've just gone to daylight saving time, so the real time is 1:51 p.m. and we are 12 hours plus from UTC. So yes, that's definitely not time in UTC, but that's definitely the image that you just uploaded.
Absolutely. Mystery solved, I think.
Mm-hmm. Now, so did you want to expand on, I don't know if you've got your astronomy software open, just pulling up those coordinates at that date when Saturn was in that position?
Let me see if I can, I don't have my, I'm sort of handicapped at the moment with my computer. I can't really pull up my normal astronomy software. Plus, this is a new desktop. I haven't even installed most of my astronomy software on this machine yet. But let me pull up Horizons.
Okay.
I hope nobody balks at the fact that this is actually a NASA website. But
well, I've got astronomy. I've got, I was going to say Astronomy Live. I've got Starry Night open here at the moment. If that's any help, I can drag that over and put the coordinates in.
Yeah, absolutely.
And let's give that a try. So I need to center other coordinates. So if you can give me those coordinates, and what I'll do before I do that is I'll just change our view to the center of the Earth. So I'm not dealing with the horizon. Okay.
Yeah,
so
and the coordinates I have are actually geocentric anyway, so that works.
Right. Now, it'd probably help if I change this view to equatorial as well, because that's the view that we're going to have from, I gather.
Correct.
Yep.
Yes.
So equatorial coordinates. View. This is as if we're looking through an equatorially mounted telescope. And center other. Sorry, what were you going to say?
I was just going to say the date as well.
Right. Okay. Let's get that sorted. Very important. So the date was?
July 14th, 1983 was the first date.
July 14th, 1983. There we go. So now we're ready for those coordinates. Send the other coordinates. Okay. Almost jumps back to my main screen, so I've got to keep pulling it over.
So the coordinates I have are 13 hours, 47 minutes, 56 seconds, right ascension.
47.
And 56 seconds.
56.0.
0.27. 0.27.
I'll make that 0.3. I think it goes to 1 decimal point on this. I'm not sure. Okay.
That's fine.
1347, 56.3. And
declination, I have -8 degrees, 28 minutes.
-8, and 28.
And 02.9 for declination, or you could round that up to 3.
03. Okay, so 13 hours, 47 minutes, 56.3 seconds, right ascension. Declination -8, 28, and is that 03, or is that correct?
03. Yes, that's correct. Mm-hmm.
Okay, so let's center those coordinates and let's see what we can find. And right in the center of the screen is Saturn. Let's zoom in on that.
Beautiful.
Okay. Saturn and all of its moons. So that's exactly at those coordinates on that date. And the other image was taken on the 24th. So I'll just zoom out a little bit. So I'll just flip that up to the 24th and let's see what happens. So it's jumped down there.
Right.
Yep.
It's moved over just a little bit. It should be about, if you move it to
14th.
if you move it coordinates 13, 48, 57.4. And in declination, negative 8, 36, 36. It should be about the same relative to position that we saw from the first date.
Okay, well, I've got this back on the 14th. Do you want me to have it on the 24th before I do that?
Yeah, let's move it to the 24th coordinates just to test that. So 13 hours, 48 minutes, 57.4.
Yep. And what I might do is I'll just put a field of view marker here. I haven't got my custom one set there. 30 arc minutes. All right, we'll just use that as a reference. So we're on the 24th, and enter other coordinates. And those coordinates.
13 hours, 48 minutes, 57.4 seconds. And
57.
then, yep.
57.4. And the declination.
Negative 8 degrees, 36 minutes, 36.4 seconds.
36.4.
Or you can round that down to 36, yeah. Not
36.
sure if we'll take a decimal.
Okay. All right, so we'll see what happens when I hit center to our position for Saturn as it is there. And this is on July 24th. And we can see it shifting.
Yeah. Basically the same relative position as it was on July 14th.
Yeah.
When we first went there. No, that's good. That's where Saturn was on that date and that time. And I pulled up those tables. So again, I'm sure Dazza will put a drop canvas link in the video description. Anyone can look at the tables. And I pulled that from NASA. Now, when I called up the table, it created a temporary link to it, but that link is now gone since it's expired. But anyone can go onto the IRS website. Let me pull that up real quick so we can put that in the video description, I guess, and call it up themselves and find out when those pictures were actually taken. It's always good to get the raw data because Google Sky, it's important to note, is not the source of any IRAS raw data. They're using a reprocessed version of the IRAS data where the sky was deliberately removed because Saturn isn't really supposed to be in the raw data. That's not really why the sky survey was being performed. And so it was removed from this reprocessed version in order to improve the quality of the all sky survey, basically.
Right.
So,
just to interrupt you, are you wanting me to share your screen at the moment?
not just yet. I'm trying to look it up here real quick. I actually want this IRSA. Here we go. Data sets. Okay, you can share my screen now. I just wanted to get over to IRSA. So this is the website where you can find the IRAS raw data in both the original unedited or unredacted form, ISSA. This will get you the images without any sort of blocking or being cut out or anything.
Just for some reason, we're not seeing your screen.
Oh, you can't see my screen?
I see your screen at the moment.
Let's see. Okay, well, let me redo the screen share. It looks like it's working on my end when I go back to the Hangout, but let me
now it's
do it.
Your Planet Express icon at the moment.
Yep. Covering the latest in the Planet Express. So, can you see it now?
No, I'm still seeing Planet Express.
That's really strange.
There we go.
Yeah.
Gotcha.
Okay. Okay. I don't know what I did there, but I think it's working now. So if you want the raw data without missing out on Saturn there, you're going to want ISSA. This will give you the original raw data from IRIS. Iris, is the reprocessed version, and this has Saturn removed from it. And that's what Google Sky used. So if I search for those same coordinates on Iris, you're going to see a black blank spot where Saturn should be.
Right.
ISSA, though, will give it to you.
Was that the reason that they blanked out that particular part?
Yes, and actually there's a paper describing the creation of the Iris data. Let me see if I can pull that up real quick. And basically, they flat out said, yeah, we removed it. And that's no secret. But the thing is, in the original data set, you can still get it. It's not like they moved it from the original data set. It's not like they're, because if they were trying to hide it, they would have removed it from the original data set, so you couldn't get it anymore. But obviously, that's not what's happened, because you can still get it from SkyView. You can still get it from straight from the website I just showed you, which is where all the raw data for these infrared surveys. So let me see here. Here we go. Let me copy this link. I have here the paper describing the reprocessed version of the data, IRIS data that Google Sky actually uses. So if I come into here, this paper published in 2005, can you see this?
No, I might need to refresh here because I can see a frozen browser screen in our Hangout, but we've just got your Planet Express on the live feed. So let me try stop presenting on that and restart it. In fact, okay, so it's gone back to me, and let me present you to everyone, and hopefully that should cure it. No, lost your screen again for some reason. What's going to happen? Here we go.
I'm going to redo my. Yeah, I'm redoing my screen share. Can you see it now?
No, we're still on your Planet Express.
So in my Google Hangouts window, I see my own screen. If I go to Google Hangouts, I see it as if it's being presented properly, which is really curious. But if we go to the live Hangout, it doesn't appear, I guess.
No, we've just got your Planet Express icon up there.
That's really.
Sorry about that, folks.
Yeah, that's really peculiar. Oh man, I guess the conspiracy theorists have taken over YouTube, and they don't want to see the truth. They can't handle the truth.
Yeah.
No, just kidding.
I remember in some of your past videos, you actually went to quite some trouble to track down the original photographic plates for the IRIS survey.
Well, no, and I have to stop you there because that's actually conflating two different things.
Okay.
Yeah, the original, I did look up original photographic plates, but it wasn't for the IRS survey. It was for the Palomar Sky survey. So there's a different, the problem is there's multiple problems with Google Sky. So that's one, the one that we're talking about tonight is from IRAS. But the one I did a extensive research in a video on is in the, I think it's either in the constellation Orion or very near to the constellation Orion, and there's a missing section there in the visible light layer, and that's from the Palomar Sky survey, and that is a glitch. The original plate isn't been missing, no one's removed it, and that's what I actually tracked down was the original photographic negative from that missing region, and compared it to a more recent photo to show that nothing had changed, that nothing was moving over there.
Right. So that was also a blacked out area of sky, correct?
Yes. But that was entirely Google's fault on that. So I'm going to paste into the.
It was from the Palomar images, not the IRIS images, is what you're saying.
Right. Exactly. Yeah. So I pasted into the local chat here inside our Hangout window, Dazza, the link to the paper. If you want to share that on your screen, maybe, since mine's having so much trouble.
Alrighty, I'll just pull that up.
And which, let's see, where is it?
So it's a PDF. There we go.
Yes.
Okay, so that's on
And if
screen.
you, okay, great. So if you scroll down to page 304 of the PDF, they'll talk about deglitching in section 3.
Did you say
and the last
3 or 4?
304.
04. I see. The numbers don't correspond to the PDF page numbers.
Right. No, because it's in the middle of a journal or something, so it's higher page numbers on the actual page. So if you scroll down to page 304, I think you've gone past it there.
The page numbers swap sides on me.
Yeah.
Right. See, it's got
I mean, literally,
it's
like a scan out of a book.
switching from volume to page from left to right. So, yeah, nearly there. 307, 305. So there's
304. Okay. Yeah, and so if you scroll down where it says deglitching and you go to the last paragraph in section 3.1, it talks specifically about Saturn. You may want to zoom in on that for your viewers because it's a little hard for me to read. Just above destriping. Yeah, that last paragraph of that section talks specifically about Saturn.
Okay, down this one here.
Yes.
Yeah, so that very last sentence there, it says, we also dealt manually with Saturn because of its large extension in the affected HCONs.
Right, exactly. So they're basically saying there that they removed it. They got rid of it. It's gone. That's their deal. And that's specific to this release of the IRIS. Anyone can technically take the original IRAS data and edit it in some way, cut a section, do anything they want with it, and then re-release it themselves and say, look, here's what I did. And that's basically what these scientists have done. And this paper was published in 2005. So unless I'm terribly mistaken, that's quite a long time after the original IRAS data was released. So it's not like they came out with the IRAS data and the next week they said, nope, never mind that. Go away, Saturn. No, this was done a long time after the fact. And so obviously there's been no concerted effort here to hide Saturn from the data. It's just that for the purposes of an all-sky survey, all-sky surveys are not designed to show the planet. Planets are problematic for all sky surveys, because at least the major planets in our solar system, because we want to see the background stars, we want to see distant galaxies, we want those points for reference for future surveys. And that's actually what this paper talks about. If you read more into it, you'll see that it talks about the reason they're doing all of this is to provide better data for future infrared surveys and even microwave surveys of the sky, so that they have references that go back to the IRAS survey, so that they can better understand what they're seeing in current images of those same regions of the sky. And so in that sense, Saturn is a distraction, and that's why they removed it.
Right. Okay. Now, just going back to some of these images, this image always makes me smile, of course, because it looks like a smiley face with a couple of little beady eyes. Do you know what this is? If I click on that, will that enlarge? Let me try that. What do we see along the bottom here? Any idea what caused the smile?
I'm not as familiar as perhaps I should be with the specifics of the, I don't know how to say, limitations or artifact processes of the IRAS survey, but if you actually put it back on my screen for a moment, I've got the colorized version of that image up, and there is something to note with the shorter wavelength images. Actually, I guess we're having trouble with my screen. I keep forgetting that.
At the moment, I believe.
Okay, are you able to see? Are you? I guess maybe not. Hang on, let me reshare mine.
Yep. It was working there for a minute. It's gone now.
It did, and now it's gone. Okay, how about now?
No, we're back to your icon. So shall I switch back to mine and then back to yours?
Yeah, go ahead and switch back. Yeah, go ahead. Just leave it on yours for now. That's fine. Anyway, the thing I was just going to say is that the detector for IRAS not as much the 100 microwave or 100 micron wavelength, but at some of the shorter wavelengths, like 25 micron, it really suffers from severe artifacting caused by residual charge left in the detector, basically, where after it passes over a bright source, the pixels retain some of those electrons. They don't all come out of the pixels like they're supposed to, and so they don't really reset back to a proper state. And so what happens, and you'll see this in some of the other images, like the ones I showed on drop canvas earlier, where you had the crosshairs and you had these long spikes coming off of those 2 points, and that's what's causing that. As soon as that detector passed over Saturn, it kept moving, and the next pixels it detected ended up being showing basically residual ghosting from Saturn. And I think that might be related to why you see that smiley face, but I'm not 100% sure. It could just be other optical effects in the detector. Obviously, though, the detector was not designed to look at bright planets. It was designed to look at very dim, distant stars, distant galaxies, and interstellar dust. And there's a lot of interstellar dust in the area, so it might be background dust, but I don't think so. I bet it's probably an optical artifact of caused by looking at Saturn, which is a very bright object to that detector, because it's an object in our solar system reflecting sunlight, reflecting a lot of infrared light, and also, obviously it has its own heat as well. So it's a very hot source for IRAS to be looking at.
Right. Okay. Now, can you see my screen?
Let me come back to your screen. Yes. Yeah, that's what I was talking about earlier.
No, I was flicking backwards and forwards while you were talking there. I'm just wondering, is it possible that these brighter stars cause that that interesting image that we see there? There it is. So it's the teeth and the smile that I'm talking about there.
Mm-hmm.
Pull up. Don't have all of the stars turned on here. Whereas our Saturn? Yeah, Saturn's up there. So now this yellow circle is a half-degree field of view. Do you know what the field of view of the IRIS survey would have been?
So that's a great question. And IRAS was not a conventional telescope in a sense. Basically, it was a single column of pixels, as I understand, and they scanned it line by line. So field of view doesn't really necessarily apply. I forget how many pixels it was. It was not that many, because in 1983, digital camera technology was in its infancy, and it was cutting edge to have pixels at all, really. And so because of it, it's a fairly small detection area, but they're scanning it line by line through the sky. Right.
Yep, that makes sense. I mean, this is a huge area. Just to put that into perspective, that is the same angular diameter as the full moon, approximately.
Yes. Yeah.
Yep. Which is a very large area of sky, really.
Okay. So. Yeah, let me, if you, oh shoot, let me, no. I tell you what, let's use the gallery to our advantage. So I just pulled up an image here of CW Leonis. Do you remember that one?
Yeah, yeah. That's a real favorite every Planet X, that one, isn't it?
Mm-hmm. So I just pulled up an image of CW Leonis, and in the 100 micron image, you can start to see those teeth forming again. So I'm now 100% sure that really is caused by the fact that it passed over a bright object. CW Leonis, for those who don't know, is basically the brightest star at far infrared wavelengths that IRAS detected. And it's been known for a long time that it's a very bright infrared object. It's a carbon star, and it's shrouded in dust that obscures its visible light, but in infrared, it's quite bright. So if you go over to the gallery and refresh it, you should see some new images that I just put up on the gallery and passed over to you, essentially.
I've got you presenting at the moment, and I think I might have figured out what the problem was. So you've just uploaded this image. No, it's flicked back to your Planet Express again for some reason. So you've just uploaded the image that we just saw. So I'll go back to the gallery now on my.
Yep.
Okay, so I'm on. No, we want to go to the main one, don't we? Which is that page.
Yes.
And let me zoom it out again. Okay, so that was the image. that you
Right.
uploaded
That was
in our Hangout. So you can see I've still got the time highlighted there. So we can see 2017-09-27, and the time was 21:51:12. That was when Astronomy Live uploaded this video to the gallery previously. So what I'm going to do now is refresh the page, and we should see that other image of CW Leonis there that Astronomy Live has just published to the gallery. And there it is, CW Leo, and the time now is 22:16:40. So this answers the question that has been raised in some recent videos. One in particular I was looking at that was raising the question about why these images are being posted as if they've been taken just today. Well, the images haven't been taken today. They've been published to the gallery today, which is what Astronomy Live has just done. These images.
So if you scroll down just a bit, just a little bit. Okay, there. Click on that 100 micron one. That's one we want to take a look at. Sorry, keep going.
Yep. So these images, of course, were actually taken years ago, and in the case of the IRIS survey that we're looking at, that was back in 1983.
Mm-hmm. So in this image, you can just start to see those forming below CW Leonis, which is the bright star there in the center. You can just see like one little band, but it's not as obvious as it was in the Saturn image, but it is there.
There we go. I can see it there. This is what we're talking about?
Yes, exactly.
And so this very dark object, is that Saturn that we're seeing in this image?
This is CW Leonis, and so CW Leonis isn't quite as bright as Saturn to the IRS detector, but it is still a very bright object, and it's just bright enough to start to form those teeth.
Right.
And so the color scale that this was set to, the prism color scale, if you look there at the bottom, the very dark blue going almost into black, that actually indicates the brightest possible object that it can detect.
Right, okay. So this object is CW Leonis, and we don't have Saturn visible in this image. Is that what you're saying?
Yes, exactly. But that was just a comparison to show you the same phenomenon occurring with those teeth forming.
Right. So these are, in fact, completely different coordinates by descension declination.
Exactly.
Yeah. Okay. Right. That makes sense. And I think there was another. Yeah, this is the main SkyView page here that you can go to. And again, I'll post the links later on when this video has finally uploaded properly. I'll update the description underneath this Hangout video with the links, along with Astronomy Live's links for the information that he's pulled up. And in answer to who I'm talking to right now, I've got Astronomy Live with me.
I think we've just about covered it.
I think so. Yep. So the smiley face that we see in these images is in fact Saturn, and they were taken over different nights, approximately 2 weeks apart. So this one here was taken on July 14th, 1983. And this one here was taken on July 24th, 1983.
And again, it's important to point out that because of the way IRS worked, it's scanning the sky line by line. And so the total image you see is composed of many different nights to be scanned and form this completed image. However, the line in which the streak on the bright streak on the right exists came from that first night, July 14th, and the one on the left from the second night on July 24th. So it ended up running over the coordinates of Saturn twice.
Right. Okay, and let me just go back on that and zoom out. So the important conclusion about what we're saying here, the question about these images and the impression that people are getting that these are the very latest images, as if you could actually look up the very latest images online, which you can't. Probably the closest thing that you...
Not unless you're paying itelescope.net to take the images for you.
Yeah, exactly. And I was just going to say, unless you've got a subscription to a remote robotic telescope site such as iTelescope or SLU, or there's a few others. There's Bradford Telescope in the UK, where you can actually book time on their telescopes, take control of the telescope, and take your own images. That would be the closest thing that you would have to live images. But certainly these online images such as Google Sky, Worldwide Telescope, maybe you can name a few others, Astronomy Live.
Sky Map and Microsoft, I think you already mentioned Worldwide Telescope. Yeah, Sky Map and a few others like that that are web-based, you know, browsing the sky.
Right. So people sometimes think that they can jump onto those sky maps, astronomy tools, and so on, and actually see live images. But that's not the case. The images were taken many years ago, and in the case of IRAS, the Infrared All Sky Survey, those images were taken back in 1983. Now, it's no different to jumping on Google Earth or Google Maps and having a look at your own backyard, at, you know, your house and neighborhood, and you'll notice that the images are not current. In fact, sometimes they can be months and years out of date, even on Google Sky. So, or Google Earth, I should say. So the images are not up to date. But the dates that we're seeing here is the date that the images were actually created by the user coming onto SkyView and actually sending the image to the gallery, which is exactly what Astronomy Live did with these images here to bring them up to date.
And somebody might raise an objection saying, well, why do they call it created if they weren't really taken then? Well, when they say created, what they really mean is the user picked out the field of view and the user picked out the color palette that would be used. So like the colors you saw, that's due to the intensity of the flux in the image. And so the color is assigned based on how bright an object is in the image. But there's many different color palettes you can pick from. There's many different settings you can set within SkyView to generate that image. And in that sense, the output of what you're seeing there is not the raw image. It's whatever they've selected. And that's what's really being created.
Right. So we can see these two images here side by side. And you've chosen different color palettes.
Right.
These two images were created just seconds apart, but we can see that it's basically the same image, but a different representation. And I'll just zoom in on where it says up the top here, SkyView, the Internet's virtual telescope. And here are images 1 to 20 out of 109. And it says submitted by SkyView users on this date. Okay. So it's not saying that these images were taken on this date. It says that these images were submitted by the SkyView users by manipulating the photos on this date.
Yep.
Yep. Okay. Well, I think that pretty much covers it. If you've got anything else you'd like to add before we close out Astronomy Live?
No, I can't think of anything. I think that's covered it pretty darn well.
Well, thank you for joining me again, and thank you to everybody who is watching and participating in the chat. And stay tuned. No doubt we'll have more for you soon. Thank you, Astronomy Live.
Thank you.